Welcome to VTeach. Now we are going to discuss how to find the open loop response as well as closed loop response. If you observe this term response, so what is this response? Response is nothing but output. That means the output of a system is to be determined for a given input. For any given input, finding the output of that system is known as finding the response, whether it may be open loop system or closed loop system. Now let us see how to find this response by means of examples. See this problem. Find the continuous time output C of t. Find the continuous time output C of t for the system shown in figure. The system is shown in here. Given the sampling period t is equal to 1 second. Sampling period given is as 1 second and given is a step input. Given that it is a step input. The input is a step input, unit step input. Then this is the output. You have to find the continuous time output C of t, right? If you observe here, the problem is given in terms of S domain. By means of using Z transforms, you are asked to find the continuous time output C of t. Now, let us take. Say for k equal to 1. So, in order to do the simplification easily, I will remove this k, replace with gain 1. So, for k equal to 1. So, this is your forward path. If you see, there are two blocks in cascade. So first you multiply those two. So 1 minus e power minus ts by s into 1 by s. Just now we have seen how to find the z transform of a function involving the term 1 minus e power minus ts by s. This is the formula. 1 minus z inverse. So 1 minus z inverse into z transform of, this is your g of s. So g of s by s you have to write. That means 1 by s by s. That means 1 by s square. So 1 minus z inverse into 1 by s square. You have to find the z transform for 1 by s square. Since it is in s domain, convert it into time domain. How to convert into time domain? Taking the inverse Laplace. What is the inverse Laplace of 1 by s square? T. For ramp, the Laplace is 1 by s square. Then z transform of t, a ramp function. What is the z transform of t? We know that it is t into z inverse by 1 minus z inverse whole square. But given that the sampling period is t equal to 1 second, substitute t is equal to 1, t equal to 1 second is given. So we will get 1 minus z inverse into t z inverse by 1 minus z inverse whole square. So these two will get cancelled one time. So what you will get? Z inverse by 1 minus z inverse. This is your forward path. So in the problem it is given as unity feedback. So your transfer function will be C of z by R of z is equal to forward path divided by 1. Since it is negative feedback, how to write plus into g of z. Since h of z is equal to 1. Gh of z, how to write gh of z. Since h is equal to 1, gh of z is same as that of g of z. Gh of z is same as that of g of z. Why? Because h is equal to 1, unity feedback. So substituting here, z inverse by 1 minus z inverse by 1 plus g of z, you will get z inverse, right? Now this is C of z by R of z. What you have to find? Output you have to find. So C of z is equal to this z inverse multiplied with R of z. What is R of z? Your input. So in the problem it is mentioned that the input as unit step. Then R of z. What is the z transform of unit step? 1 by 1 minus z inverse. So substituting here, z inverse into 1 by 1 minus z inverse. So what is the z transform of 1 by z minus z inverse? This is 1. But into z inverse is there. That means there is a shift. So you have to write 1 of k minus 1. 1 of k minus 1, which is defined for k equal to 1, 2, 3. Right? For k greater than or equal to 1 is only it is defined. So this is your continuous time output. So this is the answer for your problem. So this is how to find the response of a closed loop system. Response means output for any given input. Now take this one. So one more example, the last example. Obtain a closed form of the response sequence C of kt of the system when it is subjected to Kronecker delta input. What is Kronecker delta? Nothing but unit impulse. Kronecker delta means unit impulse. We have seen in the first unit. Second unit. So Kronecker delta means unit impulse. See, this is the block diagram. So here also there are two blocks in the forward path. So cascaded blocks. Whenever cascaded elements are there, what you have to do? We have to multiply the gains of those two. So multiply these two, 1 minus e power minus ts by s into 1 by s into s plus 1. Then finding the z transform for this. Since there is the term involved here, it is 1 minus e power minus ts by s. With the z transform will be 1 minus z inverse into z transform of g of s by s. So g of s is this one. by s, that means 1 by s square into s plus 1 you have to write. That means s domain, it is in s domain. So convert it into time domain, that means taking the inverse Laplace. How to take the inverse Laplace for these partial fractions? A by s square plus b by s plus c by s plus 1. If you do the partial fractions, you will get the values as a is equal to 1, b is equal to minus 1 and c is equal to 1. A value, b value and c value you will get. Then inverse Laplace for this. What is the inverse Laplace of 1 by s square? That is t. Then for 1 by s, 1. For 1 by s plus 1, e power minus t. Then now we will go for the Z transform. For t, the Z transform is t z inverse by 1 minus z inverse whole square. For 1, 1 by 1 minus z inverse. For e power minus t, 1 by 1 minus e power minus t z inverse. Then substituting t is equal to 1. Given t is equal to 1 second in the problem. So substituting here, you will get the polynomial here, right? Z inverse by 1 minus z, this taking 2 inside. So Z inverse by 1 minus z inverse. Then these 2 will get cancelled. So minus 1. Then 1 minus z inverse by 1 minus e power minus t. When t is equal to 1, e power minus 1. So using calculator, this e power minus 1 value is nothing but 0.3678. 0.3678 Z inverse. Now take the LCM. Take the LCM and simplify it. Then you will get the term like this. 0.3678 Z inverse plus 0.2642 Z power minus 2 divided by so and so. Now from the figure, what is the pulse transfer function? C of z by r of z is equal to g by 1 plus g, since it is unity feedback. Now here what is r of z? It is given as Kronecker delta function, that means unit impulse function. What is the z transform of unit impulse function? Z transform of delta of k or delta of t is nothing but 1. So r of z is equal to 1 here. So substituting r of z is equal to 1, you will get c of z is equal to same as that of g of z by 1 plus g of z. So if you substitute here, you will get this polynomial in numerator and a polynomial in denominator. If you observe the denominator, see, there is no standard quadratic expression. New decimal values are also there. So it is not possible to express the denominator as factors. Whenever it is not possible to express the denominator as factors, we will go for direct division method to find the inverse Z transforms. Direct division. So do the direct division. This is the numerator and denominator. Do the direct division. Then you will get a continuous, an infinite sequence up to infinity. You will get infinite sequence. So you will get like this. C of z is equal to 0.36878 z inverse 0.1036. Then you compare with the standard sequence of the Z transform. Z inverse coefficient represents x of 1, right? Then Z power minus 2 coefficient represents x of 2. Z power minus 3 coefficient represents x of 3. Then what is x of 0? Since there is no constant term, x of 0 is equal to 0. This is x of 1, right? X of 2, x of 3, x of 0 is not there. So x of 0 is equal to 0. So this is your output, C of kt. Suppose you are asked to plot, then you have to plot x of 0 is equal to 0. X of 1 is 0.3678. X of 2 is 0.16. Then x of 3 is minus 1 point. So x of 0, x of 1, x of 2, x of 3. So this is the output sequence. That is the response of a given system for the input, which is the Kronecker delta. So this is the method how to calculate the response for a given system, whether it be open loop system or closed loop system. It can be easily calculated. You can easily calculate your sequence of the output by using this Z transform method. So with this topic, I will conclude the finding the response of open loop and closed loop systems. Thank you. Thank you very much.